So before I introduce today's speaker, I do just want to remind all of you that the museum is offering docent-guided tours throughout the space. I know you had a little bit more time to look around than we intended for you to, but if you would like to have a tour with one of our docents, I'm going to ask you to come up at the gift shop. There's kind of an open space right there. We'll meet as a group, and that group can take off about 5 or 10 minutes after the talk if you'd like a guided tour. I also just want to say, if you haven't already, and the strategy of putting you in the gift shop is because we have some great merchandise for you to check out. If you have not already, we have our Eclipse merchandise. We have these really cool challenge coins. If you have not seen them already, they do show you the path of totality, which goes right through Niagara Falls. And on the back side, it kind of looks like this cool little Star Trek thing anyway. So definitely check those out. We've got the t-shirts, the postcards that you can collect from here and all of the other partner locations with NASA. The final thing I want to ask is, if you have not already stopped by our membership table, please consider doing so. Your support is so important to ensuring that our organization can continue to tell the very important role that Western New York has played in the aerospace industry and history. I know some of you here today have told me you had family members who worked at Bell, you knew people who were at Curtiss-Wright. This is a story that's so important to our community, and we are the only place telling it. Your membership makes that possible. So we really would appreciate if you would consider becoming a member today. And we are doing a $5 off promotion, any of the membership levels. Lots and lots of perks, and the wonderful ladies and gentlemen over at the table will be able to tell you more about those today, okay? So now I'm going to introduce our presenter, and I apologize already because I'm probably going to get it wrong a second time. Josiah Ruelas. Okay. He works for the Kennedy Space Center at NASA. He's originally from San Diego, California, but has moved around and lived in different parts of the United States, but always has had a passion for space exploration and discovering exciting things that could revolutionize how we live. After attending Florida Tech, he obtained a degree in mechanical engineering and fulfilled his dream of becoming a NASA engineer. He loves his family and spending time with his 2 sisters, and is an avid traveler with a goal of exploring a new country each year. His next stop will be Japan. So without further ado, I'm going to introduce Josiah for today's presentation.
All right, thank you for having me. I'm going to set this up real quick. I think this is, they said hold it down until it turns green. Okay, it turned green. So. Okay, I think, am I good? Perfect. All right, so thank you for having me. Thank you for coming out and attending today's session. I was here yesterday. We had a good crowd. Looks like we have another good crowd today. Feel free to stop me at any point during the presentation for questions. And whoever, I see some young people here too, so if I get a question from one of you all, I have limited pins that I'm handing out. So if you ask me a question, whoever asks me the first question gets a pin. But it has to be a good question, okay? It has to be a good question, not just any question. And afterwards, feel free to come up and grab some, we call it NASA swag is what we call it. So feel free to come up and grab what you like, and take some also for people you know that like NASA and are excited about NASA. So as she introduced me, I'm Josiah Ruelas. I am originally from San Diego, California. We'll go into a little bit more about me in the next couple of slides. No worries. Come on in. Just in time. Yes, sorry. I don't like hearing my own voice, so I kind of like, go away. I'm just kidding. Okay, so we'll go ahead and get started. We'll cover a couple things. We'll cover a little bit about me, a little bit about the solar eclipse happening on Monday, and a little bit about what I do at the Kennedy Space Center. So, is everyone here local? Local? No? There's who's all out of town? Raise your hand. Okay, where are you from?
Well, not too far away. Syracuse, New York.
Okay, New York. Anybody else?
Philadelphia.
Philadelphia. Very nice. Very nice. Okay, so everyone pretty close to within the area. That's good. All right, so everyone, I'm assuming, is excited for the solar eclipse happening on Monday. But totality happens every once in a while, so this is an exciting time for us. So that's why we're here. NASA, they sent out a huge group from Kennedy Space Center, from Marshall, from other parts of the states, from other centers to go out and support and do talks. So there's a couple of us all over doing different presentations at the library, here at the state park. So if you have a chance, go ahead and check us out. We're in multiple locations. All right, we already did a little introduction about NASA. A little bit about me. You heard I was from San Diego, California. moved around a lot. I wanted to work in the space industry, so the best chance I saw of doing that was working the Space Coast, which we call Florida along the east side, is because there's a ton of companies out there that support NASA missions. And so I was like, you know what, I'm going to go to school down there because I feel like they're well connected with the space industry. So that's why I chose Florida Tech. I graduated in 2020. I actually didn't have a graduation because that was right when COVID happened. So I watched myself walk the platform virtually on my sofa. So that was quite the time when I got my bachelor's in mechanical engineering. I also did some flight test engineering. So I worked on my private pilot license. Didn't get to finish it because of COVID. But I also I went far enough to do my own couple solos by myself, flying over the coast. So that was cool. Currently launch site integration engineer. We'll talk about that more. Some hobbies I like. Filmmaking. So I know there's some people in the media back there from the high school that are doing a documentary right now, so that's awesome. I made a short film a couple years ago, and I'm working on my first feature-length film now, and hopefully that comes out next year. So that's an exciting time for me. Scuba diving. As you can see, I chose the most expensive hobby, scuba diving, traveling, but you know, what can you do? Scuba diving, I thought to myself, well, astronauts dive, right? They have to train in the Houston pool, and there are divers already too. So I was like, you know what? If I want to be an astronaut, I should get my dive certification. So I ended up taking a long career path with that, and I'm currently a dive master. Traveling, she said Japan, but I'm actually going to Italy this month, which is exciting, and then I go to Japan, hopefully Japan in the fall. Career, first job was Panera Bread. So I like putting that there because for all the young ones here that have aspirations, whether it's working for NASA or for doing something else, that's a big long-term goal, you can start anywhere, right? So Panera was my first job. My second job was already working as a contractor for NASA. So what determines that is your drive, your passion, your willingness to go the extra mile to achieve your dream. So I encourage you, no matter where you start, whether it's McDonald's or Panera or whatever, you can always achieve your dream. It doesn't matter where you are. So the way I started was in Florida Tech. I applied for an internship for a contractor for the imagery team. I got accepted, and I worked on a project that had a camera system that scanned the rocket up and down. So it's like a camera system that's strung up by 4 wires. Have you seen like in pro games where they have this camera system that goes along the side of the field? So if you just take that and turn it up 90 degrees, it was a system between lightning towers that scanned the rocket. So that was my intern project. It went very well that they picked me up, and I became a NASA civil servant, a government employee, in June of 2022, working on payload integration, which we'll talk a little bit more in a couple slides. So any questions about me? Yes, sir. Never mind. Okay. Yes.
Content of your film? Can you give a...
Yes. People usually ask me, like, what do you make in a movie? No, I like dramas and thrillers and not really action adventures. I don't have the budget for that, but somewhat action adventure, but mostly drama. This next one we're doing is centered around a family, and during a kind of like a dystopian apocalyptic time. So that's where we're working on now. But that's all I can say because I haven't even released a trailer yet. So. Yes. Do I play any video games? Not as much as I used to. I'm very busy now with these filmmaking and working that it's gone down a lot. But I owe you a pin, right? All right. I'll get you a pin. Here you go. Yes, sir. What's my favorite video game? I've been playing FIFA with my cousin. Soccer. So that's my favorite video game right now. Okay? Yes.
What type of electronic do you play video?
Okay, this is the last video game question. He asked me, what type of electronics do I play video games with? So I built my own PC. So I put it all together, with the help of my friends. It wasn't just me. Put together a PC, and I also play on PlayStation 5. Yes, sir.
There's a young lady in the last row. Has a question.
Oh, thank you. I didn't see her. Go ahead.
Do I get a pen?
Maybe afterwards ask me, okay?
The last row.
Go ahead. In the blue jacket.
What's your favorite place to travel?
My favorite place to travel. So, I'll tell you that my favorite place that I've gone to recently, it was probably Iceland. So actually Iceland, you can see a picture right there. That's me, and there's I forgot the name of the waterfall, but there's a waterfall right behind me. That was just such a unique place. The landscape there was so different. It's basically from volcano activity, right? There's 130 active volcanoes out there. So everywhere you look, there's a volcano. And I know they're going through a lot of activity right now. There's a couple of eruptions going on over there currently. But Iceland was so unique. You could just drive off the side of the road. There's not much. You could just walk wherever you want to walk. There's not much out there that can harm you. They've only spotted like 500 polar bears in its history out there. There's no dangerous snakes. None of the wildlife can hurt you. So it's really safe. You can go out there walk anywhere you want. And you just got to be careful of the water because the tides are a little dangerous. But Iceland's probably one of the favorite places I've visited. Yes, sir.
What was your high school focus before you went to college?
So my high school was a bit unique. I was homeschooled through grade school, and then I went to high school, a private school, my freshman year, because I wanted to play sports. And then I did dual enrollment. So I actually wasn't too much into science. My focus was more the arts. So I got my Associates of Arts when I graduated high school. I did dual enrollment.
So you weren't
in college.
totally a math person?
I wasn't totally a math person. Nope, I was not.
What do you do at NASA?
What do I do at NASA? Well, we're going to get into that. You're going to see it real soon about what I do for NASA.
Do I get paid?
Ask me after, and maybe I'll have a couple extras for you, okay? Alrighty. Okay, we can keep moving on. All right, before we hop into this, let's go over the solar eclipse real quick, if you can, for me, switch over. So I'm going to switch over to the solar eclipse presentation. I'll do something real quick here, because I'm sure you've heard this from Lester and others already. So the solar eclipse is where our main priorities: safety, broadening participation, science, public engagement, which we're doing right now, science activation, and citizen science. So we'll keep going. Did Lester show these slides? No. Okay, all right, just double checking. So then, this is just a graphical illustration of a solar eclipse, as you can see on the left-hand side, and then a space view of what it looks like here. So you can see the shadow is casting on Earth. This is a total eclipse, so there's only a select locations where you'll see a total eclipse. Others you'll see a partial eclipse. So this is my first time seeing a total eclipse. I believe it lasts, correct me if I'm wrong, I think it's like 3.5 minutes of totality, something like that. Don't look at it with your bare eyes when it's partial eclipse, right? Wear your safety glasses. I believe you have some at the front desk. So get a pair of safety glasses. Look at it, and then once it becomes totally covered, you can tell it'll get dark. You can take it off, and you can look at the corona part and see the moon cover it. So just be careful when it gets to partial eclipse not to look at the sun. Protect your eyes. Yes, sir.
How fast does the Earth spin?
How fast does the Earth spin? Oh, you're gonna get me. Go ahead.
So at the surface of the Earth, it's going about 1,100 miles an hour. The moon travels in the same direction, about 2,200 miles an hour. So the moon will travel across the surface of the Earth at about 1,100 miles an hour.
So pretty fast. Yes, sir.
So, Mike, how does the sun change when the moon goes in front of it? Is that it's stronger?
So the sun will stay the same, right? What's happened? Or you asked the question, does the sun?
Like, are the glasses, will you bring your retinas if you just look at the sun with the naked eye normally?
Yes. Yes. So you're asking will you hurt your eyes if you look with the naked eye? Yes, that's correct. So that's why we wear the safety glasses first.
But even if it's not an eclipse, will you hurt your eyes?
Yes, even when it's not. Let me finish his question real quick. So when the moon passes in front of the sun, right? All that's left that you really see is the corona. That won't hurt your eyes. You can look at the sun with your bare eyes when the moon is completely covering the sun, because the moon is blocking out all the harmful part that would hurt your eyes. So you're able to look at it with your bare eyes when it's completely covered. Okay? Yes.
Why did the sun, when it was burnt, hurt your eyes faster when it's not so good, or when it's not full so good? And would it burn your eyes hurt as much, or the same?
So you're asking if it's a partial eclipse, will your eyes hurt?
Yeah, as fast.
as fast. So it's probably not as bad as when it's the full effect of the sun, right? Even with the partial, it can still cause harm. So you want to be careful and wear sunglasses.
The point there is when it's partial, it doesn't hurt as much, but it does as much damage. So you think it's not hurting you, but it is,
Right.
as opposed to when it's not partial. So always wear your solar eclipse glasses except when the moon is in front of it. And at that point, you're not really looking at the sun, you're looking at the moon.
Correct. Yes. I'm sorry, I didn't catch the question. Lunar eclipse? I'll let you answer that question.
Lunar eclipse,
I can.
Go ahead, answer.
A lunar eclipse is basically the opposite of a solar eclipse.
Mm-hmm.
The Earth covers up the moon, while solar eclipse, the moon covers up the Earth. And lunar eclipses are much more common,
Mm-hmm. Very good.
and also known as the bloody moon.
we learned yesterday, do you know what they call it when the sun's between the Earth and the moon? Apocalypse.
Yeah, it's a bad day. Okay, let's keep moving through here. All right, so this is the path of totality. So here you start in Mexico and you go up the United States, and this tells you the different times. So we're right around here. 318 is when we'll see the totality, and then you can see it'll continue up the United States. So this is the only path of totality that you'll see. So me being down here, I couldn't see anything, so that's why I'm up here with you guys. So, yes, sir.
Would it be like 2:18 a.m. or p.m.?
It'll be 3:18 p.m. on a Monday. 3:18 p.m. Yeah. He asked what time the solar eclipse was, the p.m. or the a.m. Good thing it's not in the a.m., right? Because it'll be dark anyway. So, p.m.
Are there any other countries that are going to see the eclipse like we are?
I know. Well, you have Mexico here, Canada here. I don't know if it goes up to Greenland. Is it? No, it doesn't go up there. Okay.
No.
'Cause that's
South? North
just
America?
where we are.
It figures out in the
Yeah. Okay.
How far does the solar eclipse go? How many miles does it go?
How many miles does the solar eclipse go? Not sure. Not sure. Across the whole United States, and then, as he mentioned, it starts to go out in the Atlantic Ocean after Canada here. Okay, we'll keep moving ahead real quick. Solar eclipse glasses, we talked about this already, so we'll keep moving forward. This is just the different.
Solar glasses work.
How do solar glasses work? Well, there's filters on there that filters out the bad stuff that will hurt your eyes. So that's what help. Without getting into too technical terms, they have filters on the glasses themselves that help filter out the bad.
How can you see through the filters?
Well, they're special filters. Yes, sir.
In the image you had of the states, if you go back there
Yep.
for just a second, the shape of the moon is elongated there as you see the top. What is causing that there? What's the difference between the elongation?
So you're saying that the circles change?
The more circular at the bottom, yeah, and then you get up there and it's more, at least in this image, is something happening that we might see something different than someone in Mexico was seeing?
Go ahead.
It's true. That's not the shape of the moon. What that is the in those time zones, how long it'll be in totality.
Okay.
And that's due to
Yeah.
the fact that the moon is, there's craters and mountains and ridges around it. It's that sort of thing.
Okay.
Very cool. Yes.
Why does the path of totality curve?
Curve because you're talking orbits, right? So that it's not going to be a correct. You probably can say something technically better. I'm sorry. Why is it curved, right? So
The Earth
What
rotates.
does the solar
yeah. The Earth rotates a certain way, and also where the moon is, it rotates a certain way. So that's why you get a curve. It's not a direct single line. You have two curved surfaces.
does the solar eclipse look like on another planet?
Similar. If there's an eclipse, it depends on where the sun is on a different planet. It depends on a lot of different things. All your celestial bodies are in the solar system. It will depend how it'll look. So I can't answer that because we haven't been there yet. But we'll get into a little bit more about what we're doing in the future, okay? So we'll keep moving through. So total eclipse. Oh, also what's really cool about the eclipse, I saw this in a partial eclipse in Florida. The shadows that get casted from the eclipse are unique. It becomes like a pattern. So if you see a plant, or if you just want to do it with your hands, when there's an eclipse, look down and look at the shadow it casts. It's not a direct translation how it is normally. A pattern effect happens. So it's pretty cool. Mm-hmm. Some science that we're doing when on the corona part, right? So normally when the sun is in full effect, the corona is covered by it's hard to see the corona because of the brightness of the sun. But a few studies that we're doing is looking at how strong and far our radio signals travel, and the impacts on the ionosphere. So that's some of the science effects we're doing. And then solar radiation, and also looking at the magnetic hot spots also there. How do we know this about a solar eclipse?
Yeah, how long have we knew about what actually a solar eclipse? There's no back in time the clock was a creature eating.
So how long have we known about a solar eclipse? Probably back in...
So Newton knew about it,
Newton.
and so did Ptolemy.
Uh-huh.
And the Babylonians for over 700 years took data about everything they observed, and Ptolemy, someone he lived, reviewed all that data to predict the next
Okay.
while.
Yeah, and I know now that with our technologies available, we're able to predict patterns, right? So when they are, we can now look into the past and see when the solar eclipse were in the past, because based on the patterns it's showing today. So, yes, ma'am.
So can you talk about what the corona is? Because people keep mentioning the corona. Can you talk?
The corona is
It's a
the
good-
outer atmosphere of the sun.
Yes.
No, you can't see it. The sun is so bright.
Yes, so the
So
corona,
when it blocks it, you can see it.
right? It's the outer atmosphere of the moon itself. I'm sorry, did I say the moon? Of the sun itself, and also it has effects on solar wind that we get. Solar wind has effects on our atmosphere as well. I don't know if you have anything to add about that one. Okay, all right. Yes. Yes, that is true. Yes, so she was mentioning that when the total eclipse happens, if you don't take off your solar eclipse glasses, you won't see the corona. So that's why you take them off, you can see the corona.
How hot is the sun?
How hot is the sun? Super, super duper hot.
What is the sun made out of?
I'll get back to you afterwards. We're going to keep going through because we have a lot to cover today, okay? You said helium. All right. All right, so I know we have a lot of questions already. We're going to switch back. Don't worry, you'll get a pin, okay? You'll get a pin. All right, payload integration. So you asked me a lot about solar eclipses and things like that, and luckily we have a lot of people here that know about that too. But the portion I work on is more specific on ground processing. So if we jump over to where I left off, there are a couple missions that I'm working on. Artemis 1, 2, 4, and 5. So we just forgot about 3 because I guess it's not important. I'm just kidding. No, I'll work on 3. It's just not on the current scope of work for me currently. There are people working on 3. It's just right now my current missions are these. So Artemis 1, anybody see the Artemis 1 SLS launch? Anybody in the room? Yes, yes. So that was the first test flight of the SLS vehicle, which we'll talk in a little bit. That was NASA's flagship rocket that went up November of 2022. It was successful. I believe it had a 99-point-something% success rate of the mission. It was unmanned. We were even to achieve additional objectives that we weren't planning to do. So that was the first flight that flew in November of 2022. Artemis 2 will be a crewed test flight. So this time we'll have crew aboard, and there is an astronaut too in the area that will be on that flight, Artemis 2. It will be a crewed flight. It will go around the moon, come back, and land in the Pacific Ocean.
Is it going to launch from Florida or?
So you asked if it's going to launch in Florida? Yes, it will launch at the Kennedy Space Center, Launch Pad 39B. Yes.
So I am a place in Central Florida, will I be able to see it?
On a good day, yes, you can see it. I think I've heard people on a clear day seeing it from even beyond Central Florida, the other side of the coast. On a clear day, I live about an hour south of the Kennedy Space Center, and I can see the small ones go up on a clear day. So you'll be able to see it, yes. Yes, sir, in the red.
What is the mission getting? Were they trying to find something out?
Yeah, so this whole presentation is about that. We're going to get all into what Artemis is about and what we're going to see. So that's a great question. We're going to see all about what Artemis' mission to the moon is going to be. I'll go with you first. I can get back to you if you want me to. All right, just raise your hand again and I'll come back to you. Yes, sir.
How often does the eclipse happen?
How often does a solar eclipse happen? Do you know the answer to that, how often it happens?
Well, there are solar systems. They happen over the Earth, different points often.
Yeah.
And so when they happen for any given location.
Right. It's different all over. Right.
Next time in the U.S. is in 2045.
Yeah. Yeah. So. Okay. So Artemis 1 launched in November. Artemis 2, that's the crewed flight. That launches in September of next year. So that'll be the crewed test flight. Artemis 3 will be actually landing on the moon itself. And we'll kind of go over what that looks like in a little bit. So what I do specifically is I work the ground processing for Artemis 1 and 2 of these CubeSats, so that they're shoebox sized, right? And they're packed with science instruments that do Earth and moon observations. I believe one of them was actually attempted to land on the moon itself. So there are different configurations, mostly the size of the shoebox. They get loaded into the vehicle and launched, and they're developed by universities or other space agencies. So we launched 10 of them, and I worked on those. Artemis 4 is my main job. Artemis 4 is when we get into Gateway. So I heard Lester start talking about Gateway a little bit. So Gateway is a lunar outpost. Is everyone familiar with the International Space Station? So the International Space Station is huge, right? I think it's equivalent to a 5-bedroom house, and with all its solar arrays and all of that is, I think it goes up to like the size of a football field. So it's massive. But this Gateway is a much scaled down version. We're not even calling it a space station. It's more of a lunar outpost, right? It serves as a transit location for astronauts launching on the SLS or a commercial vehicle to dock with the Gateway, enter through the Gateway, load themselves into a lander and go down to the surface of the moon and come back, spend more time in Gateway, get back into their vehicle that got them there, that takes them back to Earth. So Gateway is a deep space proof of concept vehicle, right? It's going to teach us a lot of different things so that when we attempt to go to Mars, we'll have the lessons learned from having the vehicle like Gateway up there already orbiting the moon. So Gateway is a huge part of what we're doing for getting to Mars. And the module that I'm working on, right, so Gateway is assembled by multiple modules. The module that I'm working on will have the crew, that's where the crew will sleep and eat. So it's called the International Habitat Module. So that is being developed by the European Space Agency. So I work with them a lot. That's why I'm going to Italy. And so we are prepping for the ground processing of them at the Kennedy Space Center to make sure that when they arrive, everything goes well, that we need to do all the checkouts and everything that needs to happen to get stacked into a rocket and launched. So yes, question.
Why is a spaceship when you're in space? Why when there's no gravity? Why do you go like up?
You don't necessarily float up, right? You can stay in place when there's no gravity. Depends on where you are, right, in the terms of pull from gravity. But when you're in space, you don't float up. You're pretty stagnant, unless you exert a force onto yourself, and then you can go in a particular direction. So if I wanted to go up, I'd just probably push. I'll go up until I stop myself, or else I'll just keep going, and keep going. Yes, sir. When do I think we'll get to Mars? It'll be a little bit. I think there's a lot of, we have to get to the moon first again. We have to prove that Gateway works as a vehicle, right? Those launches are happening, through 2030. So if we get to Mars, it'll be probably sometime after that. So we don't have anything in the books as when this is when we're landing on Mars, but we have to accomplish our first mission and prove that we can live in deep space prior to making those decisions that we're going to go to Mars. So, yes.
How big is the moon?
How big is the moon? I don't have the exact dimensions, but I'll look it up to you afterwards, okay? And I'll tell you. I gotta keep going. Let me keep going. I'm about 20 more minutes. Let me keep going. Hold on.
How big is the sun?
I'll answer your questions afterwards. Okay, I got you. Don't worry. Okay. Artemis 5 is another module. It's a refueling module. You see this gold structure on the outside of the main structure? That holds xenon in there that provides the refueling capabilities of the gateway. So I'm also working on that, but that's a little bit further out. So that's going to be also processed at Kennedy Space Center and launched on the SLS rocket. So we have different configurations of the vehicle we're launching. So this is the SLS Block 1 vehicle. This launched in November. This will launch for Artemis 2 and 3 as well. As you see here, you have the boosters, the main core stage, which holds your fuel, and then you go into the elements that the launch vehicle adapter, ICPS, Orion, and this little structure here is where the crew sits, and then you have a launch abort system up here as well. The CubeSats that I mentioned, you see these little dispensers here? They get put into these dispensers, and then this section right here goes about right there. And then so when you're in space, when this part of the rocket goes away, these get deployed, they're spring-loaded, they get deployed into the appropriate location to do their experiments. And then the crew continues to travel for their mission. So that's the SLS Block 1 vehicle. It flies Artemis 1, 2, and 3. Artemis 4, which I talked about as my main mission, is a little bit different. It has a compartment that goes right here. Some people might be familiar with the name a fairing. We call it a USA, but it's like a fairing. It will hold the gateway module, the module where the crew will sleep, that orbits around the moon. It will hold that in the rocket itself, and also Orion, where the crew sits, will be on top of that. So the rocket's taller. I believe that Block 1 is 322 feet. Block 1B is, I believe, 360-something feet. So it's a little bit taller than the Block 1 vehicle, right? So when you're in space, I don't have a picture of it, but when you get to space and you're left with this part of the rocket, and this is connected, this is all connected right here, Orion will actually detach in space, turn around, dock onto IHAB, pull it away from here, and tow it the rest of the way to the moon. So Orion is towing IHAB all the way to the gateway to connect it to the gateway, and then they can enter through IHAB into the gateway lunar outpost. A little bit more about what I do. We talked about IHAB a lot. So I'm in charge of planning the flow from when it lands, right? Lands at our launch site to it being processed, right? So in this phase, you have a lot to do. Installations of batteries, installations of cargo, equipment. Sometimes people need air, you need clean air, you need all sorts of commodities that go into processing a vehicle that's going to be operating in space. Next up, you take this to a hazard processing facility and you rotate it to the vertical orientation. We have these heavy-duty cranes that will lift the vehicle up and mate it to an adapter, right? This adapter is part of the launch vehicle. And then you have what here, this is the USA, the fairing that I call it, that will be lifted up and over and then enclose IHAB so that way it's protected from when you're in space or launching when you're in space. It protects IHAB from the environments. So we call that encapsulation. So it encloses IHAB, and then we take that through a transporter to the VAB. Everybody familiar with the VAB? Vehicle Assembly Building. I'll show a picture on it, but it's a massive building with 4 huge high bays that fits a whole 365-foot rocket inside of it. And that's the Vehicle Assembly Building. So then you take that element now, this element that has the payload and the adapter, and you lift it over into that high bay and you stack it on top of the rocket here. So now you have a complete stacked rocket at the launch pad. Yes, sir?
What if people would think it was a good idea to go to space?
There's a lot of useful applications in space, right? So you might have used a GPS when you came here, right? You know Velcro. Velcro is something that we used from and we learned from and developed for space. there are countless applications and patents NASA has put out there. You can look it up on nasa.gov that we have released and that people have learned. There's medical supplies that people now use, navigation, all sorts. Even if you look at the weather in your phone, well, what's the temperature going to be like tomorrow? That comes from our satellites, our space weather satellites, and that predicts a lot of things for us too. So there's a lot of useful instruments and a lot of useful technologies that develop from us going into space. Yes, there's a question in the back. Not a good day. Not a good day. She asked what happens when you run out of gas. It's not a good day, but luckily we have really smart people working on these type of things that have reserves and contingencies in place, right? So it's not an exact, we need 5X amount of fuel to get to this location, right? They built in contingencies. So we have 10, we have 12, we have 20. There's factors of safety that's built in so that just in case you run out of gas, you have reserves you can pull on. So there's a lot of safety that goes into this for considerations, especially for crew. Yes, sir.
What type of fuel does it use?
So there's liquid hydrogen, and oxygen are the primary.
Plasma.
Plasma, no, not plasma, not yet. But liquid hydrogen and oxygen. Okay? Alrighty. So humanity's return to the moon. So what is helping us get there? So there's 3 main programs, several supporting programs too. I'm not knocking any other programs. There's several other programs. But the 3 programs that are helping us achieve a mission with this rocket right here to get to the moon is the Exploration Ground Systems program. That's the program I work for, right? We develop a lot of the ground infrastructure, the ground capabilities for processing a vehicle, and for launching the vehicle, right? So we manage the launch of the vehicle itself. The Space Launch System is also another program. That program is in charge of the development of the rocket itself and its components. And then you have the Orion program, which is, Orion goes on to the SLS vehicle, but Orion's in charge of the development of the Orion spacecraft where the astronauts will sit. There's 3 programs that are getting us there. Exploration Ground System I talked about. What I didn't say is we also do the recovery. So, right, you have this whole rocket here, but all this rocket is essentially doesn't come back, right? A lot of this goes away, and what's left is this Orion spacecraft. And when Orion comes back, it splashes down in the Pacific Ocean, and we have a Navy ship that goes up there. We have divers that go out there, boat crews that reel it into the ship, and we get our astronauts out of the Orion capsule safely. So we do that. We were in charge of the recovery also of the spacecraft. Vehicle assembly building. It's huge. It's a massive building. Luckily, I have the good fortune of being able to park in front of it every day I go to work. So it's nice. Sometimes I take a selfie and I send it to my sisters, and so it's just really cool to be around. It's 525 foot tall. It takes 45 minutes to open and close the doors. So not necessarily this door. There's doors on the side that you can't see that are along the high base, and there's doors go up that almost 525 feet tall span, right? So they take a while to open and close. You can fit 3.5 Empire State Buildings in there. Not vertically, okay, you take them apart and you can fit them in there. But there's 3.5 state buildings in there. That American flag is a little bit cut off here. The blue portion is a full-size NBA basketball court. That's just the blue portion. And yeah, so it's a massive building built for the Apollo era rockets and still used for the shuttle and now used for Artemis. The mobile launcher. So the mobile launcher is how we transport the vehicle, right? So we have here a crawler transporter, which only goes a couple miles an hour. I think it goes only like a mile an hour when it transports to the launch pad. It can carry a lot of weight, and I think there's a closer-up picture, which I'll talk about more in a second. And then on top of it, you have a mobile launch platform. This is the structure that holds the launch tower here. This, for perspective, is about 2 to 3 stories. I think it's in 3 stories in some locations, but 2 stories. And then you have the launch tower, which has what we call umbilicals that come out and hold the vehicle and also provide power, data, and different things like that to it, clean air. The crawler transporter. So this is a mean machine. This thing is heavy duty. It's like a whole separate spaceship. I was able to go onto it one time, and it's really cool. For some perspective, these shoes right here are 2,000 pounds each. So that's each 2,000 pounds all around, and there's more on the other side too. So it's heavy duty. This is our launch pad. This is where we do our launches here. Yes, ma'am. Say it one more time.
How many tubes to build a rocket ship?
How many tools? A lot, probably millions of tools. How many tools is built to build a rocket ship is, I can't even count. Can't even count. Yes, sir.
How long
How long
will it take to build a rocket ship?
it took? So this program, I believe it was Constellation. I don't know if you have the top of your head how long it takes a while, especially when a new vehicle. Let me get back to you. I don't want to give you the wrong number. So let me get back to you, okay? We can come up and I'll look it up. Yes, in the red.
When they were setting up the Challenger, what was the malfunction that made it explode?
So Challenger was the 1986 one. Yep. So that was the one that exploded on takeoff, right? So that was what happened was there was a foam piece that came off, and the foam piece had O-ring. I'm on the wrong accident. Okay. All right, so the O-ring linked in. Yeah, so it was the coldest night beforehand, right? It was a cold night. The O-ring froze, it cracked, and then I believe what caused that was that the structure of the connection between the booster and then the vehicle.
Solid rocket boosters had sections.
Right.
The seam between the sections allowed some of the combustible materials to come out instead of going down and burn the tank.
Yeah, it punctured the tank, and then when they took off, punctured the tank, and that's how it happened. Yeah. So, yes.
What is the rocket's material is usually made out
Rocket's material. So it's several different things that you may
of?
know.
Outside layer.
There's different. So it's different per segment, right? There's different sections. Solid rocket boosters are separate than what the core stage would be built. But I don't know the top of my head exactly the material composition of it, but I can get back to you. Yes.
Is it dangerous to be outside when the rocket launches?
Yes. But not only in a certain area. So I believe for SLS, it changes per vehicle. But SLS had about a mile or 2 miles where no people are allowed to be within. Because of the sound and the vibrations, it can cause harm to a human. So honestly, it could be fatal too when you're that close. So there's a zone that no people are allowed to be in. You have to be a certain distance out. So I was about 3 miles away for the launch. Yeah, and you're safe in that area. Oh, yeah. Okay. Launch pad, real quick, just some features of the launch pad itself. You have a flame trench right here that when the vehicle launches, the flame gets directed in this trench into this direction. So that way the flame doesn't go out in this area, but this flame trench forces you out. The crawler takes you all the way up, sets it on the pillar, this platform here, and the crawler exits out. So that's how that works. It's obviously without the vehicle, but this is what we would do with the vehicle as well.
Does some of that grass get burned?
Mm-hmm. Yeah. Even the bricks will fly. It'll tear up some structure. Maybe we had a little bit of damage from Artemis 1, right? They had to go in there. It's expected, but you'll get a ton of damage from the rocket itself. So, and then you have a crew that's ready to, a fire crew that's ready to go out there and extinguish anything that catches fire or something like that. So we're well prepared for it, but yes, it burns a lot. Yeah.
Are those 2 towers here for lightning?
Yes. You asked me if these 3 towers are here for lightning protection. They are. So we have 3 towers here that are for lightning. There's actually really cool photos online about lightning striking when the vehicle is at the launch pad. And so they redirect the lightning down to the ground away from the vehicle. So that's the lightning protection system we had there. If you remember the camera system I told you about, my camera system was hoisted between these 2 towers here that went up and down. And you can actually take an elevator up here. There's an elevator. I would never do that, but you can do that. All right. And then here's your tanks for hydrogen and oxygen. You have your tanks back here. I think they're building a big one over here for greater capability, but you have your fuel tanks back there as well. Okay. Launch Control Center. So I talked about data, sending commands and stuff like that to the vehicle. How that is routed is to the Launch Control Center. So this Launch Control Center houses all the information we need to process the vehicle and launch the vehicle. You can see here, this is our launch director, Charlie Blackwell Thompson. She runs the show on launch day, right? She has the command of no-go or go authority. And you have all these people on the floor, experts on different systems, so electrical, power, propulsion, all these different things that they all right here inform the people up here what's going on, and then ultimately it's up to her to make the decision. So a lot of folks go into this, but this we call it the firing room. This controls launch day right here. So a very important room. Landing and recovery. So landing and recovery is what we do. We talked about before. It lands in the Pacific Ocean. We have crews that come out and take Ryan back into the Navy ship safely. It tows it in, and there's an opening back here where it tows it into the Navy ship, which you can't really see from this angle, but there is an area there. Yes, sir. You're asking, is there food in Orion? Yes. Yeah, so Artemis 2 is about a 10-day trip, so they'll have food on board that will sustain them for 10 days for the crew. Yeah, there is food. When they come back, yes, there'll be food for them. We have to be careful because they've been without gravity for 10 days, right? So you have to carefully take them out, and there'll be food and warmth and a room for them to stay when they come back. Yes, sir.
How long does it take for the people to rescue them?
How long does it take for... Say it one more time.
How long does it take them? How many days or weeks it takes when it in the water for the rescue?
So it just takes a couple hours. It doesn't take weeks. They get them out pretty quickly, right? So it doesn't take that long for them to get to here to there. So I would say, I don't know the exact number, but a couple hours, not on the order of days or anything like that, weeks.
Wait, isn't the Pacific Ocean is the home to the Bermuda Triangle?
The Bermuda Triangle is in the Atlantic. It's the other side, so we're safe from the Bermuda Triangle.
What if on the other side? Can't if you're other side?
Yeah, we're safe from that. We're okay. We got the Navy ship there out to protect us. We got helicopters watching over us, so we're pretty safe.
But a bunch, over 200 people disappeared in the
We're safe from the Bermuda Triangle. Don't worry.
And helicopters and planes too.
Yeah, we're safe from the Bermuda Triangle. We're a little bit far from it. Okay. Artemis 1, we talked a lot about Artemis 1 launching successful, so I'll keep moving through. Artemis 2 is so they're not going to land on the moon, they're just going to go around the moon, and they'll be in this capsule testing on our systems and make sure we're ready to go for the landing itself. And that's just a picture and the 4 astronauts in the crew cabin. I think they're doing some testing here. You can see they're definitely not in space. This thing is open. So. Artemis 3 is landing, right? So this right here does not look like what the lander will look like, and this is not the suit that the suit will look like, and there's no wind in space, but but it's for effect, right? Or he moved it out, and that's how it looked. But this is just an illustration of how we look when we land on the moon. Our lander we selected. I'll talk. Yes. So the lander, there was a couple calls that went out. SpaceX is handling the first landing mission for Artemis 3. So this is a concept, but this is something similar to what it'll look like when they go on the moon. So are people familiar with Starship? Boca Chica? So Starship is launching, and they're doing their test flights. I think they had a good flight this last launch. So we're highly dependent upon their success, right? Because Artemis 3, our NASA's rocket, is dependent upon SpaceX rocket because that takes us down to the moon's surface, right? So we're all heavily reliant upon each other. So we're rooting for SpaceX for their successful Starship launches for land on the moon. So they have to launch a couple times in order to get the Starship over to the moon. So they're trying out new capabilities like refueling in space, things of those nature. That would also teach us how to go to Mars because we'll have to refuel a couple times to get to Mars if we were to go to Mars. So we're hoping for their success, and that lander will take us down to the surface, our crew.
So that's separate from the other rocket? This is a separate
Yes.
thing that's going to be there?
Correct.
Onto their route?
So there's Gateway, right? So we'll have the SLS launch vehicle, which we talked about. That will take either the crew and also a module, a component of the Gateway with it to Gateway. So add on to the Gateway lunar outpost with that module. The crew exits Orion I'll have a picture a little bit later, but the crew exits Orion from the SLS rocket, and then attached to Gateway is also the HLS, which is the Human Landing System, which would be the SpaceX portion. So they're already attached to it. So the crew just exits the Orion, goes through the Gateway, hops into the lander, and then the lander takes them down. And the lander takes them back up to Gateway. They exit the lander into Gateway, and Gateway goes into Orion, and Orion will take you back to Earth. Did I lose you guys?
Where does it attach onto this thing?
So they're still developing. This is just a concept, so you're probably not going to see it very well here. But there will be a docking port on this vehicle that will connect to. Yeah.
It stays on and it's back.
Yep.
The space shuttle.
Yeah, it's like a little transit system, right? So in order to get this there, Starship has to get it there. So Starship is the tall metal structure that they're building in Boca Chica, and then that will launch you into space and get this lander to Gateway. Yes.
Shouldn't, when you land, shouldn't that, when they hit the water, shouldn't that blast them heads up in the air from the landing?
So they have to be very careful on the landing, because also it kicks up lunar dust. So lunar dust was a surprise, I would say. Maybe I don't know if a surprise is the right word, but in Apollo there's a lot of lunar dust that they weren't expecting. So if you go to the Kennedy Space Center, you can see all this lunar dust on the astronauts. So they're looking into ways to mitigate the dust of landing and also working on the moon. Yes, in red.
So I know SpaceX is like big on their AI and that stuff. And yesterday, dude was talking about how like they blow the stuff up if something goes wrong, and that SpaceX uses AI. So sometimes do they just send AI up in space? SpaceX, do they just like send nobody up and just like AI?
So right now you're asking me about how they launch and if like unmanned versus controlled by itself, right? So these test launches, since they're new vehicles, right, they have to be tested out and make sure they're safe for crew. So they'll be unmanned, right? So I'm not sure how many times Starship has launched already, but the last couple of times, all unmanned, right? They're proving the vehicle can work. SLS, the first one, was unmanned as well. And then we know it's safe. We know we got a 99% success rate, so we know it's safe for humans. So we're going to put humans on the second one for that. So a lot of it's all automated, right? It can fly automated. We're just verifying that it's safe for humans before we put them on there. Yes?
What's the point of getting to Mars?
What's the point of getting to Mars? That's a great question. There's a lot we don't know yet. Mars looks like it had water before, which is a big sign. There's some stuff at the caps of Mars that we want to explore, and also exploring how the different atmosphere is on a celestial body, right? And also we've learned a lot from the moon, so imagine what we can learn on another planet, and that we could also possibly live there. So how would we live there if we needed to go there, and if we needed to stay there? So there's a lot of lessons to learn about how we get in and out of the atmosphere of Mars, how we could grow plants on Mars, and how we can do different things so we can grow food and eat, and if we need to be self-sustaining, we can do it on a different surface. So, okay, one more question, we'll keep going.
Isn't Earth like kind of dying, so that's why I'm trying to get to Mars?
So we still have we're good on Earth, right? We have a while. We're exploring different areas, and the human spirit, right, is to explore. We have explorers throughout history, and that's what our drive is, to go explore. So Mars would just be a complement to here on Earth, but we're doing okay on Earth, as long as we keep things clean. All right, let's keep moving on. I'll keep capturing. I know I'm a little bit over, so let me just get through the presentation, and if we have time, we'll get more questions, okay? All right. So landing on the moon, this is just another graphical depiction. The lander doesn't look like that, but you can just see some rovers here and some things like that to go. Apollo had rovers. I don't know if you've seen those videos of those guys riding on the rovers. It's pretty cool. But similar here, you'll have some rovers. Gateway. This is a little bit maybe better to what you were asking me earlier. This right here is Orion. This right here is IHAB. So IHAB has already been attached, but if this wasn't here, Orion would take IHAB and dock it to this, and then this came later. But Orion, when it arrives at the gateway, it docks to here. The astronauts that are in this cabin exit out, and they can stay here for a little bit if they want, if they do some experiments and things of that nature, and then they dock into a lander, which is right here. And they all load up into the lander, and this lander will take you down to the surface and back up. And then the astronauts come out of the lander, hop into Gateway. They could chill a little bit, do more experiments, and then hop back into Orion, and Orion will take you back to Earth. So that's...
So that stays in space.
Yep, so this structure right here stays in space and orbits the moon. It's mostly unoccupied. It's not like ISS where it's constantly occupied. The Gateway Lunar Outpost will be mostly unoccupied. So it'll be orbiting. Yeah. So it's not just being built by NASA, there's other commercial partners as well. So SpaceX is actually launching HALO and PPE, which is HALO is a habitation, I forgot the A, but logistics outpost. And then the PPE is a power propulsion element. So there's different elements that are coming together, being launched by different entities. So we're launching one, SpaceX is launching another one. So it's all under the umbrella of the NASA Gateway. We're all working together to build up a space flight system that's capable of operating around the moon. So this is just another picture of the HLS. It's a little bit redundant. And then Mars, we talked about Mars a lot, right? So this is paving the way for us to get to Mars. And then this is just an inspirational message. Let's go. The time is now. And then this is just my LinkedIn and my email. If you have any questions or want to reach out to me, you're more than welcome to. Yes, sir.
So for people with questions about Gateway, we have a 2 o'clock presentation about Gateway.
Okay. Yep. So you have a 2 o'clock presentation about Gateway if you have further questions about Gateway. And I know we're a little bit over time. That's all I had for today. Do we have time for a few more questions? So we have time for a few more questions if you have any questions right now. Okay. Oh, I got a couple. So yes, you in red.
You said that you do stuff.
Yeah.
I've done short films and stuff like I
Uh,
actually push myself like in captures.
All right.
That stuff.
I'll text you. Sounds good. Yes.
SLS, how many planned missions are there for that rocket?
So right now I think it goes up to 9 or 10. What we're looking at, like in the immediate term, is right now 5. But there is, I believe, I'm trying to remember, but there's 10 or something like that Artemis missions out there. So there's a lot, and it'll keep going until we get otherwise. Right? We'll keep launching, we'll keep exploring. So there's a lot out there. Right? There's a new there's new boosters we're building for it and things of that nature. So we're building capability as we go along throughout the Artemis missions for the rocket itself. All right, any other questions? Thank you.